Hello friends, and welcome to the next tutorial of this series. In this tutorial we will be conducting a two-way ANOVA test over the given data set. In the given data set we have the two different varieties of products. We have the super product and we have the best product, and we want to consider the effect of temperature of these two products. Like these are the two different varieties of detergents, and these are the various effects of temperature, and we will be conducting a two-way ANOVA test to see whether there is a difference of these temperature on the functioning of the different products. So we have defined the three null hypotheses for the two-way ANOVA test. Like for the null hypothesis, the H1 hypothesis is that the means of the observation grouped by one factors are the same. And the second hypothesis is that the means of the observations grouped by the other factor are the same. In the same way, we have defined the third null hypothesis, that there is no interaction between these two factors. Now, in order to conduct the two-way ANOVA test, we need to first of all click on the data ribbon over here, and then we need to select the data analysis pack, and we need to consider the ANOVA test with replication and click OK. So we need to define the input range. So in this case we have to provide the input range. We can provide the whole of the data to the input range, and always make sure that your data is in the same form so that we can conduct the ANOVA test. So it should always be in the same form, as you can see from the structure of this data set over here. And now we need to provide the rows per sample. As you can see that we are having the 4 rows per sample, so we will be entering the value 4 here, and we have also defined the value of alpha to be 0.05, and for the output options we will be obtaining the output over here on the same worksheet, and then we click OK. So we need to give this. So this is the two-way factor, the two-way analysis of variance, the two-way factor with replication, and you can see that these are the values for the analysis of variance with two factors, and you can see that these are the values. You can see the summary statistics for both of these products. Like we have the summary statistics for the super product, the super item, and we have also the same summary statistics for the best type of item. That is so these are the various parameters for both of these categories, like this count, the sum, the average, and the variance, in the same way for the best item as well. So and you can also see the summary statistics for the total or the all of these products as the summary of the statistics over here. You can see that there are a number of observations. The number of count is 4, and the sum is 20, the average is 5, and the variance is. So these are the basic summary statistics for both of these different items over here. Now this is the ANOVA table. This is the ANOVA table. This is the ANOVA table, and you can see that there are various rows and various columns. In the rows we have the sources of variation, like we have the sample, and we have the columns, and we have the interaction. Like we have also defined the 3 null hypotheses over here. We have defined the null hypothesis of the same factor. We have defined the null hypothesis of the other factor, and we have also defined the null hypothesis for the interaction factor. So these are the 3 source of variation for the two-way ANOVA factor, and now we will be checking the different values of the ANOVA result, ANOVA table. Like we have the sum of squares, we have the degree of freedom, we have the mean squares, we have the Fisher value F statistics, we have the P value, and the F. This is the value for the F critical. We have seen that. So now we will be considering the value of the F statistics and the F critical value to accept or reject the null hypothesis that we have defined here. So now for the first case, for the sample source of variation, we can see that the F value is quite greater than the F critical value, and the P value is quite less than the alpha value. So we will have to reject the null hypothesis that the means of the observations grouped by one factor are the same. So now we will be considering the other factor, the other column source of variation, and we can also again see that the F value is quite large as compared to the F critical value. So again we will have to reject it. So we will have to reject that the means of the observations grouped by the other factor are the same. So now in the third interaction factor, we can see that the F value is 3.476 and the F critical value is 3.554557. So we can see that the F value in this case is smaller than the F critical value, and the P value also is greater than the alpha value. So we can say that we can accept the third hypothesis, the third null hypothesis, that there is no interaction between the two factors. So we can accept this, the third null hypothesis, and so this is the way to conduct the two-way ANOVA test in Excel, and you can conduct the ANOVA test in this way, but you need to make sure that the data set is arranged in this way. Only then you can conduct the ANOVA test. So I hope this video is useful. Thank you.